Alright guys, so now we are actually going back 2 chapters in our book and we'll be starting on chapter 6. And this chapter actually deals with shapes and more things that you would more traditionally associate with geometry. So it should be hopefully a little bit easier than last section. So let's talk about something we already know, right? If we have any triangle, we know that the sum of its angles, interior angles that is equal to 180 degrees, right? So what we're going to do now is we're going to try to apply a rule to all different types of polygons, right? Like a square or a pentagon. So what the first theorem we'll learn in this chapter is the polygon angle sum theorem. Okay? Now what this polygon angle sum theorem says is that the sum of the measures of the interior angles of any n-gon, or polygon, where n is the amount of sides that polygon has, is going to be equal to n minus 2 times 180. So let's quickly show that this works for triangles, which we already know that the interior angles of a triangle add up to 180 degrees, right? So we can see here that for a triangle, which we would say here is a three-gon, right? It's a polygon with 3 sides, or more colloquially known as a triangle. We would have the measures of the interior angles of a three-gon would be equal to n minus 2, or 3 minus 2, times 180, right? And that would obviously be equal to 1 times 180, which would be equal to 180, which we already know. Okay, so using this theorem that we know, that we've just learned about finding out the measure of the interior angles, let's find out what the sum of angles A, B, C, and D would be, right? So here we have a rectangle. And a rectangle, I would say, is probably known as a four-gon, right? Or has 4 sides. So the measure of the interior angles of a four-gon is going to be equal to n minus 2, or 4 minus 2, which is 2 times 180 degrees, or 360. So what we're saying here is, because of this theorem, we know that the sum of angle A, B, C, and D is equal to 130 degrees. Let's look at a pentagon. Angle A, B, C, D, E has 5 sides, so n would be 5 in this equation. So we would have 5 minus 2 times 180, or, as you can easily see, 3 times 180, which will be equal to 540 degrees. So once again, angle A, B, C, D, and E is going to be equal to 540 degrees. And lastly, we have a polygon that has 1, 2, 3, 4, 5, 6, 7 sides. 1, 2, 3, 4, 5, 6, 7 angles. You notice the number of angles is always equal to the number of sides. So we'll have 7, this is a 7-gon. So 7 minus 2 times 180, or 5 times 180 will give us 900. So angle A, B, C, D, E, F, and G all added to each other will equal 900 degrees. So this leads us into your first question for tonight. What is the sum of the interior angle measures of a 13-gon, polygon with 13 sides? So what is the sum of all the interior angles added together of a 13-gon? All right, remember again that I will be answering the questions in class tomorrow and not on the video anymore. So now we will be looking over a definition that you should probably already remember, a regular polygon. So remember, a regular polygon is just a polygon that is equilateral, which means all of its sides are of equal length, and is equiangular. All of its angles are also congruent, right? So what we're going to talk about is what we can say about the angles of regular polygons, right? So let's look at this corollary down here. This corollary to what we just learned says that the measure of each interior angle of a regular n-gon, right, a polygon with n amount of sides, is n minus 2 times 180 over n. Now, we just learned that the sum of all the angles themselves is equal to n minus 2 times 180, right? So all we're doing differently here is dividing by n to find each of the angles. And we'll look at that in a second. So we have a triangle here, right? So this triangle has 3 sides, so it's a 3-gon, right? So let's just find out the sum of all its angles. So we'll have 3 minus 2 times 180, which is again equal to 180. So now we have these 3 angles that are all equal angular, or the same measurement, right? So if we wanted to find the measurement for each one, we would say, well, that's equal to 180 is equal to x plus x plus x, or 3x. So if we wanted to find the measure of just one of these angles, it would be x equals 180 over 3. And you see how this right here, what we just found, is this formula up here, right? Where we have a 3-gon, right? We have 3 minus 2 times 180. That's the top part. And now we're just dividing it by the total number of sides, n. And again, we get 60, which you already know, right? That the measurement of equal angular angles in a triangle, right, is 60. The angles of an equilateral and equal angle triangle are always 60. So now let's do it for a rectangle, right? This time we can probably just trust our formula, since we just showed why it works. So we have a rectangle, or a 4-gon, right? So we would say that the equation would, when we plug in the numbers, say 4 minus 2 times, times 180 over, again, n is 4, would be equal to 2 times 180 over 4, which is equal to 90. So putting in n for this equation right here, we get that each angle of this square is 90 degrees, which makes sense, right? A perfect square is made up of 4 right angles. So this kind of further proves our point that this equation works. Now, I can't stress this enough to say that this corollary right here, this formula right here, only applies to regular polygons, right? If a polygon isn't regular, again, remember up here meaning equilateral or equilateral and equiangular, then we can't just assume that all the angles are the same size and we can just divide by 4 to get each individual one, or divide by 3 to get each individual one, okay? So if it's not regular, you have to just go back to understanding that they all add up to n minus 2 over 180, and then solve each one kind of independently. Okay, moving on to exterior angles, right? You guys remember what exterior angle is, right? An exterior angle is just an extension of one of the sides, and then it's the angle in between that extension, and then one of the sides of the polygon. So what we're learning here is that the polygon exterior angle sum theorem says that if you add up all the exterior angles of a polygon, then they will add up to 360 degrees, okay? And that kind of makes sense. We know that 360 degrees is a circle, right? So what we're kind of saying is, let's say we're starting here, right? So first we're going to take this angle to go here, then this angle to go here, then we're going to add on this angle to go here, this angle to go on here, and finally this angle to go on here and end up in our original spot, right? We basically just kind of did a circle. We kind of just did exactly a 360-degree circle. So that's how I remember it, that if you add up all the exterior angles of a polygon, they're going to equal 360 degrees. So with that in mind, we're going to move on to question 2. Here we have a 1, 2, 3, 4, 5-gon, a pentagon, if you will, but definitely not a regular one, right? The sides are not equal or anything. So what I'm asking you is to please find the value of y of this exterior angle, knowing the other 4 exterior angles. Okay, so now we're going to quickly talk about what we can say about exterior angles of regular polygons, right? This last question was not a regular polygon, so we could not assume any sort of trick or formula, right, for the last exterior angle. But here, let's look at a couple of regular polygons and see what we can tell about their exterior angles. So right now we have here a regular triangle, right? Equal angles throughout all the interior angles. And we can see that we also then have equal exterior angles, right? Remember, an exterior angle is just basically a linear pair with one of the interior angles. So if all the interior angles are the same, that means all the exterior angles are going to be the same, right? Look here again, a regular square or rectangle. Oh, square, sorry, not rectangle. Again, you can see that the exterior angles are all equal to each other. Again, 90 degrees. And lastly, again, we have a regular pentagon. All the interior angles are equal to 180 degrees. 108 degrees, sorry. Which again, we could calculate using the equation n minus 2 over 180 over n for this. If we put 5 in, we get 3 times 180 over 5, which is equal to that 108 that we see inside of that pentagon. So we could solve for those angles if we wanted to. But more importantly, again, we see that all the exterior angles are equal to each other. So what we can say about the exterior angles of regular polygons is that they also have a formula that can determine the measurement of each one, right? And it seems to be that we know that no matter what, the sum of all the exterior angles is going to be equal to, 360 degrees, right? So it seems to me that there seems to be a trend that the measurement of each exterior angle is going to be the total amount of angle sum, if you will, divided by how many exterior angles there are, right? So for the triangle here, there's only 3 exterior angles, and since they're all equal, they must equal 120 degrees. Here we have a square, right? The exterior angles have to add up to 360, and there's 4 of them. So that means each one individually has to be 90 degrees. And again, lastly, we have a pentagon here that has 5 exterior angles, right? So that means that each angle being the same measurement, if we divide 360 by 5, we, of course, get 72 degrees. So that would be our last kind of formulaic correlation we can make with irregular polygons. Remember, all these kind of assumptions that we can make about every angle in a polygon comes just from regular polygons. We can't assume anything about non-regular polygons, right? Look at this mess. That is a nightmare. You can't assume anything from that. But if you know that they're regular, if you know that they're, all the angles are equal in the middle, all the exterior angles are equal, then that's when you can make assumptions like this, just based off its size, based off how many sides it has. All right, lastly, I'm going to leave you with 2 questions. So first, I'll ask the first one and pause the video for you to answer, and then I will let you do the same thing for the 4th one. So, question 3, the first question. Find the measure of any interior angle of a regular 8-gon or octagon. Okay, and lastly, please find the measure of an exterior angle of a regular 8-gon or octagon, right? So the first one you're looking for the interior, and now you're looking for the exterior angle.